Hello everyone, my name is Simon Munyomugo. I'm an expert in PCB design, and today I'm going to do a simple project on home automation, which is going to be very helpful in automating your home and allowing you to control your lighting system, your sockets, switches using a phone. So you're going to do a PCB design that can do the automatic automation of your homes. And today I'm only going to focus on the schematic and the PCB layout. And then maybe in our next video we shall focus on programming the microcontroller. The type of microcontroller we are going to use is the ESP32, which is a very important microcontroller in automation of your homes. More so the lighting system, and we shall be controlling it through the Bluetooth or the Wi-Fi system. So let us start on the requirements for this project. Control save. We want to save it to desktop. Articles. This article we are going to save on new. So you have been saving all our projects here, so I can open on a new folder, and in this new folder we want to save it as ESP32. This is requirements or components that we need in order to do this project. So we can open it like that, then you can save as requirements. So we go on. The first requirement that we shall need is the 12 volts adapter. The other requirement is the ESP32 which has a Bluetooth control and a Wi-Fi control module. And then another thing we shall have is the DC motor. Although we shall not really utilize it today, but DC motor is the one that will be controlling your bulbs, your lighting systems, your sockets, your taps, and so on and so on. The fourth one we shall be having is the voltage regulator. And this one should be something to do with the BMI 7805 T. And this one, the purpose for it is to give us 5 volts output. 5 volts output. Then number 5 we shall be having capacitors. And this one should be 470 ohms farads or microfarads. And then we shall be having DC female jack. And then okay, this is a port for powering the system from 12V adapter. Then we shall be having a female header. Number 8 we shall be having 10 resistors, that is 4 in number. shall be having BC547 transistors, BJT of course, and they shall be 4 in numbers. Then we shall be having SPDT relays, 12 volts, and again they should be 4 in number. And then we shall be having many other comments as we go by, depending on the demands of the program. Again, we can have a voltage regulator, and this one is a 3V3 volts. Okay, and so on and so on. And finally, we shall have screw terminal blocks. It should be 4 in number. 4 in number. So that's all we need as our requirement for this project, and the other things shall be following. So we are going to start to draw the schematic. We start to draw this schematic, and we shall start by now powering our system. We shall start with the 5 volts power source. You can see our input is 12 volts, but our system requires around 5 volts power source. So let's get started. File, new project, ESP32 home automation. Want to do it afresh. So important, but no, not really. Workspace. You go to articles, then new, then requirements, then you save it as ESP32 home automation schematic. I'm stuck with our schematic. So this is where you start your project from. Your schematic. This is the surface. We have different tabs here. You can see them, but you can do some settings on the paper. The date that you're doing this project is this. The title is ESP32 home automation project. The company is me, Simon Mugo. Then you can have other comments like where I come from. I come from Mumias West technical and vocational college. So you can add as many components as possible. Mechatronic engineer. I'm a mechatronic engineer by profession. Okay. This is the first revision, so there is, in fact, it's not a revision, so but you can put it as first revision, and so on and so on. So landscape, and then you can click OK. Then let's see what we got here. These are the details we are entering now. The title of our project is ESP32 home automation project. We have my name, we have a mechatronic engineer where I work from, and so on and so on. So you can see this is how the title block will look like. Then you can try now to start our project from the end. And the first thing we are going to do, we are going to start with designing of 5 volts power supply. So first stage, step 1, designing of 5 volts power supply system. This 5 volts power supply system will be required in order to power our ESP or ESP32. So it's very important you start from there as you go. So let's get started on our designing of a power supply system. So we start by placement of our components. That's what you do. So you wait. the placement of our components. Correct. So the first thing you're going to place is the barrel jack connector. Barrel jack connector. You must be very keen when choosing the type of barrel jack connector. So barrel jack connector DCJ200. The description, this one is DC barrel jack connector. You cannot pick on just any barrel jack connector. You have to be very, very keen while choosing them. So this one has 3 terminals, and it's barrel jack connector, DC power jack. Then you have this one again, barrel jack switch. That's a switch. So barrel jack mounting. So I settle on this one. Okay. So M for moving. Hotkey M is for moving. So I can move it there and then I can control save. The next component you're going to place is ground. So A. Let me place ground. GND. Okay. I place our ground somewhere there. So I can start doing a connection. So wire W. So I can move ground, move to come and have the connection there. And then you can connect this one, number 3 again. We ground it. We don't require all these terminals. They are connected to ground. So you need to ground it like that. Control save. Next component that we need to place here is our voltage regulator, and our voltage regulator is BA1 is 7805. So you can adjust 7805. This is a 1 amp. BA1 7805. So we need to add some of these features. So I can try to search them here. BA1 7805. You can open the file location. I want to show you how to load some footprints when they are missing in your schematics. So you have this one like this. So we can come here. We can extract to alias. And then I can get it extracted. So you can go back to the top. We see the extraction where it is. It's here. So like this. Then I can copy it. I come here. Yeah, that is where I have put several footprints that are very important for me. So this is where I have put my footprints. So I can paste here. Correct. Then I can go back now to my schematic. Before now here, you can come on preference. Manage library symbols. So I can add, because I want to add my new symbol. So you can come, you can look for the BA. I've not added them here. It's here. You can see the KiCAD footprints is there. Oh no, what's not happening? So like that, you can open it. You can rename it BA1. BA1 7805 T. Okay, then now you can come back to A. Then you search BA1. Here you go. You have the symbol. It's here now. You can see here. Then you can click OK. Then you can place it where you wish. Control C. So you can come again and search for the datasheet of this component here, so that you can understand some few things that are very important. So you search BA17805 7805 T. Then you write datasheet. Then you hit enter. The datasheet will help you to understand how to make the schematic. So you open the datasheet. Where is it? Download. Click here. It is. So this is the datasheet, and in the datasheet you will have to see several things. So you have to look for application if it's in this datasheet. If not, there you can look for another quite almost similar to this one. So this one is giving us a complex, not a good one. You look for a good datasheet. And this datasheet is very important. They will help you. Yes, I can use DigiKey. DigiKey is the best website also when you want to source components and you want to search components. So sometime you can try to search in DigiKey or JLPCB or PCB, PCB Gogo. All those are manufacturers for printed circuit boards. So this is how you look at it. Okay. You can try again to look at 7805 datasheet. It will give you the schematic, because that one is a generic 7805. So you can go to 7805 directly and look for it, datasheet. Okay. Silicon supplies. Open datasheet. Okay, voltage operator. So you see, here we have how you have to connect it. This is how it's done. Are we together? So you have to connect. You have to calculate these capacitors as they are. Then you connect them the way they are. So we go back to our schematic. We do this connection. So the first thing, wire. Like that, control save. Then we have to place a component which is a capacitor. So and this one I will choose to use a polarized capacitor, but I will use the American symbol. Okay, I place it there. This one I'll edit the value. Hotkey is V. They are confusing between wire. The hotkey is V. 1C capacitor. Then here on capacitor I will put 470 microfarads. For me, this one is better. Move symbol a bit. We want it to come out of. Then we can wire it. You connect it like that. Then this one you can wire it to the ground like that. Control save. Then you can go to the other side of the connector. Of course, ground is connected to the ground, so you copy the symbol, you move it to this point, you take it wire, and then you connect, move, yes, like that. Control save. You go to output. Then you shall be having another capacitor of 470 capacitor, like that. Wire, connect, you ground it. Control save. And then you want to have an input of 12 volts, so you can hold 12 volts positive symbol like that, and pick it, come and place it there. Then you do the connection of wire to this point like that. Control save. And then from there, now this is a 5 volts voltage regulator, so the output here shall be 5 volts. So you come here, you take 5 volts like that, you click OK, you place it there, then you add wire, you connect it, control save. So you want to give it a label, you don't leave it like that. So you come to view, you come to place graphic text, then you pick it where you want to place it, and then you name it 12 volts. And 5 volts. 5 volts power supply. I'll make everything in caps here, because I have chosen caps. Then I want to reduce this one to 1.0 to 1.2, then bold, then OK, then I place it there. Then I can add some border lines on this, project, for it to look smart. Control save. Yes, you can see these are our 12 volts and 5 volts power supply. So you can go to the next point of this project. We want now to do the next step. We come here, step 2, designing trim power supply system. Designing a 3x3 power supply system, which is also very important when it comes to powering of our schematic. So we'll come again on placement of components, and we shall look at LT1086. So LT1086 at 1 amp, it gives us 3 volts. We have this one, so 1 3v3, so this one is correct. Fixed output. We place it there, control save. Again, you can go and look for its data sheet. You see how it's connected. But for me here, I have no problem with any connection. So let me try to expand it. Not that big. Yes. So we start. We copy this one, because we need to power this from 5 volts like that. So now I can expand it so that you can see what is happening here. So wire, so we can escape this wire like like that. You power it there. Control save for V in. Then you have our capacitor. And the capacitor can have electrolytic here, like that. Wire, connect it there, control save. Then you have capacitor. You can place another capacitor now. This time round, you're not using electrolytic, you're using an polarized capacitor. It's not happening with the search tool. So capacitor, small and polarized, correct. So wire, connect it. Okay, then let's check on something here. After we do that, we have to check at the values of these capacitors. If you check on the data sheet, you'll see these values: 1.0 UF as one of the values, which again will reflect here. So V for value, which is again 1.0 UF. If you check at the data sheets of these type of transistors that I'm using here, you will see that way. So we copy ground from here. Copy ground, place it there, copy it again, place it there, copy it again, place it there, and then connect. Wire, correct. Wire, correct. Wire, correct. Then now, because we want to show you what is coming out of this, it's a V3 voltage regulator, and therefore we have to make sure that we indicate that one. So you go to value again, no, not value, you go to placing component by pressing the hotkey A, then you go to 3V3, you search, it's here, positive, correct. Come and place it there, and then wire, connect, control save, and you will have completed. Then you label this one, you go to place text 3V3 power supply, 3V3 power supply, then you hit OK, you place it there like that. The text is too big, so I can delete and make it uniform as the rest. So you can go again and place. Then you say 3V3 power supply. Then we had agreed that I'm placing it 1.1 like that. Then you add some borderline, some borders. Control save. We go on. So we are going step by step. You have done the power supply for 5 volts. You have done the power supply for 3 volts. And now we are going to the next step, which is a very, very important step now. Very important step in this project. Very important step. And in this step, we are going now to place our main component for the project, which is the ESP32. There's 2. You can see this model here. It allows the use of Wi-Fi and so on. The input voltages, on-board antenna, and it's an SMD component. So you can choose either way. They are just all the same. They are just all the same. But for me, let me settle for the first one. This is our first component. Now the project is taking shape. Control save. Let me reduce it a bit. You can see now the project is taking shape. can see it's very clear. And what is important here, first of all, is to power. We have 3v3 pin, so you need to power it. So you come here, and then you copy. You go, you take it somewhere there. Then you take wire. So you take wire like that, Control C. So it's time to power the components. We have already powered our system with 3 volts. So we go now to 1033. We want to start shaping our project. 1033, we have to place a resistor first, R, so component A, then resistor, small, but I don't want, I want US symbol. I like the US symbol. I don't know why, I like using the US symbol. Then I can rotate R for rotation, and this one is being placed at 1033. Like that. Then you connect at pin 27 wire like that. So this one we can edit the value 3, and this one is 10 kilo ohm. 10 kilo ohm. Yes, 10 kilo ohm, which is in our card is written as 10K. And then we place another component, which is our transistor. I just use BC547. Yes, which is an NPN transistor. Place it there. You pick wire. You connect it. The project is still taking shape. Then after there, we have to place our another component, and this component now is our relay. And the type of relay that I want to use is RT314. So relay here, you can check out RT relays, types of relay. You go to RT. Now I can also search here. So RT. 341. RT31 4A. All these one you have to do some research to get these components, the components that are best suited for the project. So I decided to settle for this one like that. Then I placed it there like that. Then wire, connect it. It is connecting. Then you have a diode. You have to place another component in. And this type of diode is very simple to get, which is one N for 1007, and then I take the 7, the other one 7, which is this one. Okay. R for rotation. This one is correct. Like that. Wire. This one steals some power from here. Then we will be having 12 volts input, so I can place it instead of searching it there, copying. So 12 volts like that. We want to power this relay. That's the importance of the 12 volts that we are having from the other side. So wire, you power our relay. You come like this, like that. Control C. So you can see the importance of the 12 volts input. It's having a lot of work here. A lot of work. You can still go on. power other components. So this one you can place. We want to ground this one, so you go to ground and enter, place it there, copy. Oh, sorry. So for ground wire your ground like that, the component is connected. We want to place another component which is a connector, con underscore 01 times 03 generic. This one you place it there. Wonderful, wonderful, wonderful. And on this one again, we have to tap from pin number 12 here, wire. You go, oh, sorry. Can use it. You come here, you power this one. You copy this ground, copy. You bring it there. You wire it like that. Control C. Then you take from pin number 11. You take it to pin number 2. So that one is connected like that, and you have it complete. And we need to connect 4 devices in our component. This one here we have connected. This one we will be connecting our bulbs here. We will be powering bulbs. So I can add some notes here. Where is it? Notes. You can place text. Then you can put this one is for printing. Click OK. Place it there. Now we need to do several projects. We can do as many as, or we can connect as many projects as you need using this same system. For example, let me choose to add another one, because in our requirements we had placed some DC motors here. So these DC motors are the one that will be doing the control. So this one is for lighting. And you can decide to power other systems too. So, and to power those systems, you can do this way. You can copy this because it will work as the same as from that point to this point. You can copy. No, I need to copy. This is 33. I need to copy it. So copy, if it doesn't work. Copy doesn't work. So you can duplicate it. Again, duplication doesn't work. So let me try without using shortcuts. And then I do this. Control C. So we need another connection. So to demonstrate a bit, if we need several projects to be done using this same ESP, you can come and do connections of another circuit like this one. So you can have as many circuits like this one connected to these pins. All these pins are for connection. All these ones, all these pins, except RXDO and RXTDO, except those 2 pins. So for now, I will just use that one to demonstrate, because you only want to power the lighting. So I'll only use that one to demonstrate what I'm talking about. So I'll copy, control wire, connect, control C. So this was our third step. I forgot to label it here. Step 3, ESP32. to or schematic connection. So that's how our ESP32 schematic connection should look like. This is the main connection. So what we do, you can add some borders too on this one. It won't cost us anything to add some borders. We respect it also as part of my project. It won't. Just like that. Just like that. And we shall be already having our project. Now we want to lock all the pins that we don't need to avoid shorting during the manufacturing. So all these ones you have to show that you are not currently interested in them. You don't need them right now. The remaining part of the project, this is how you do to them, or this is what you do to them. Sorry. That one has gone correct. Control self. You can see your project. This is a nice project, by the way. This is a nice project that can help you automate your living room via phone. Yes. So let's go to the next part, which is annotation. Annotation complete. You close. The annotation, you check the electrical rules. You run. Then you can see. Then you close. So we need to add a power flag here. Where else we need to add a power flag? We have only one part, one bit. Okay, let's add here power flag and here power flag. Then we see what will happen. So a symbol, then PWR for power flag. Rotate R. Yes, like that. Copy. Bring it to the other bit. Where is it here? Add. Another one. Where is another one? We look at the place where you have been given some warning. And I did a power flag. Oh yeah, this one, number 14 is not connected. So we need again to, because you don't need it, come here. You don't add a power flag there. Then we control save. Control S on your keyboard. Then run again. Finished. It's a good project. The next bit is to add some footprints. Let's add some footprints on the project we are doing. Footprints are very important because they are going to allow us to proceed to PCB layout. Without footprints, I don't think whether you will be able to proceed to the next level. So footprints are very, very important when you're doing your design work. Very important. Very, very important. So let's wait for them to load. And I have a lot of footprints in this system, so it might take some few minutes of our time. But we will be able to proceed. There is no problem. We can wait because we need to learn, isn't it? Yes. So okay, because we need to learn, we can wait. And this will be another very nice video. Yes. The following error card, there is no problem. So we have some symbols that have footprints assigned on them already, like this one, this one, this one, this one, and this one. So we start with capacitor, SMD, and I always like the code of mine, which is placing the code of mine 1246, this one, again on the other capacitor, and on the final one. So they are similar. Then you go to barrel jack. On barrel jack, we'll come here. Then we try to look at what is available in the footprints. It's rare for me to use the barrel jack, so I have to confirm which is better for this project. Okay, we don't have footprints. There's no problem. Horizontal barrel jack. Check out the footprints of this horizontal barrel. Okay. The barrel jack, screw terminal block, I'll touch the barrel jack. So there is no barrel jack with a 3D shape here. Oh my goodness. I think I'll have to... Oh yeah, here we go. Oh my goodness. Here we go, we have one. I thought we didn't have any, but we have one. So we can add this one. Barrel jack. And then connector. We will go for the screw terminal block. So S for screw terminal block. Okay, it's not a must to use a screw terminal block. We have so many types of connectors. We have USB, we have WAD, this is the word connector. It has a 3D footprint. No, not complete. I don't want to waste another time trying to add components. The ST connector. We have so many types. So HI connector, phonics connector. This is the phonics connector. What do you want? Not a bad one. So I can use the phonics connector. Not a bad one at all. Not a bad one. Okay, then resistors. Of course, I'll come here, set for R, go to resistors, SMD, then go to my obvious code, which is 12. This one. Then 3v3. For 3v3, you can try to search for B. TO22. So what do we do? We go to T. Then we can go to packages. We have SO, we have TO, SPIP. Which is this? Let me check out this one. MT. Yeah, packages. We have so many types of packages here. We have dips and this is a diode. I don't need a diode. Let me check this one. We see. Oh no, this one is a diode again. Very tiny. Okay, let's check it out. Yes, SOT package. Let me check this one. Whether it has a symbol, a nice symbol. Hey, not a bad one, but I don't like it. So this one is it house. Let me see this one. Okay, I still don't like this one, so we can go on differently here. Try to look at it again, but they don't have. No, this is not for unsoldering. No. I don't want unsoldering holes. No, I don't want that. I don't like that one. You can try to go down here. We see what is happening. Not a bad one, but I don't like it. Texas instrumentation. Okay, this one for Texas. It's very tiny, but it's not a bad one. Okay, let's do see. footprints. I can try to use this one, and this one I can also edit it and try to use another simpler one. So again, I can try to go back to footprints and see whether I can get identify footprints for this one. I can get a better one. So I go back to packages, TOS. This is a nice one, very nice one. But before I go to that one, let me check on others. Not a bad one too, but I can check this configuration to find a new one. Let's see. Oh, this one has no footprints. Let's see this one. Okay, this one has no footprints too. It has pins. So we are there at DSM, and we try to look at this. So it's DSM. So we look again at it. We check at it. Nice one. So you see now I can't have it, you know. Correct. So we can continue. Okay. That's how to add some footprints. So we go to netlist generate. No, before we go to netlist generation, let me save. Control save. You go to netlist generation, so you generate the netlist, you save it, there is not much. Then you go to BOM generation, you generate it, success, close. Then now we go to the real deal. In the real deal now, the real deal, you come here, you go to update the PCB, update, we have one warning error, something J1 pad is not found in connector, barrel jack, horizontal. There is no problem, but we can correct it. You can move everything to the center here. Then we can enlarge everything. We can enlarge everything. Control save. You can see this is our PCB project. Let's try to view it before you arrange anything and see how it looks like. Wow, this is wow. This is wonderful. It's a nice project. It's a nice project, as you can see it. It's a nice project. So it's a nice project from the look of things. Yes, and this one will power your lighting system. Therefore, so we have to arrange it accordingly. The first thing to move is this connector. So we move. You rotate like that. Control save. View. Let's view it. Should it be like that? No. This one should be facing from the outside. So again here, rotate, then move like that. That one is correct. Then this barrel jack connector, move. Place it somewhere there. And come and fight with it again. The one is 4V5, move. 5 volts power supply. There. Where's for the 3V3, move. Place it there. This is our main component. Move. I come to this one, move. Like that. Let's watch again. Let's view. We see how things are taking shape. Yes, you can see it's taking shape. It's taking a lot of shape. So we can come here. We can try to edit our. We can try to edit. Just taking the pad only. So we can try to edit. We want to edit footprint or 3D shape. This one so Z. Reduce. Oh, this one is moving. No, it should not be moving. We want to rotate offset. Oh, it's scale. And scale it down. Let me see how it looks like. Okay. 3D view. Got it there. I still need to scale it a bit. Down. But not bad off. So you can scale this down again. Scale it down. Okay. Let's view it. Scaled it too much. So scale up by 2. Okay. Maybe it. Yes, that one is better now. It's better off. We come to this one, you rotate R, then you move. Let me see it in a 3D view again. Yes, it's taking shape. So we have the 5 volts power supply. So we can, oh no, sorry, on the symbol, you can move. Okay, this one, you can move. We have the 3v3. Move. Let's move somewhere there. 3v3 and capacitors. This one can move to this point. What else we have? We need to move this one, so we can move this 3v3. You can move this on a bit like that. You can move this one, move a bit there. You can have this one moving a bit that point. This one was going together with a diode. This one LM90 something diode move. So you can move it here. move. Give me space, give me room. Give me room, move. Give me room. Like that. So this one can move, but a little bit. Then we take this one, move. These are not a resistor. We need the 10K resistor. This one, move. It comes here. We rotate. We need to rotate it. I don't think so. Move. This one now. Move to somewhere there. This one move. Should be there. This one move. It should be somewhere there because they are for 5 V-volts. Move. I want to move this one. Move. R for rotation. Move. 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 Move again. So Control save. Take this one, move. Take this one, move. Take this one, move. Then you take this one, move. Then you go to view, you see what you're getting. Wow, this is wonderful. Oh my goodness. Very wonderful. It's something wonderful. Let me expand it a bit. You see. So you can edit color. You can try to change color. Preference, color, you come to solder mask. Yes, solder mask color. Font, can pick on red. Okay. So these are things are as per now. These are things are as per now. Now we go to routing our project. Before routing, we need to create our edge cut. So you select edge cut. We want to pick it from here. We can add. Okay, they were there. Yes. Now we start our edge cut. Our edge cut. Edge cut. Now we view again. You see what you're going to get. Now you're getting defined. What? Like that. We need to mount our system, and we can control save. And if you want to mount our system, we need to add a mounting hole. We need to add a mounting hole to our system. So mounting hole. When 2 and pad, that is correct. Come here. Place it. Add another one here. Okay. You place it. So our board, we have decided to just do 2 mounting holes, so you can view again with the viewer. Yes, you can see now you have your mounting holes with pad in them. This is what makes this thing beautiful. So after adding the mounting holes, you can control save. Then you can start now drawing your so we can start doing our routing. And before you route, I want to change my track to my preference. I want to do better tracks. So I can add my tracks, like using 0.78 as my tracking, as my path for the tracks. Then you start drawing your track. Oh, I did not select. So you come here, then you select. Then you start now doing your tracks. This one is wrong. You can see this track is forming a 90 degrees angle, which is prone to wear and tear. So what you do, you remove it, you continue. You have to form the 45 degrees angle. You don't have any reasons not to form the 45 degrees angles like that. You don't have. So you go to the next one. You go to the next one. So we are routing directly there. You go to the next one. There. You go to the next one. There. You go to the next one. There. Go to the next one. There. Next one. Now you can see this one. There is no way you can escape from here. So you have to add a via, hit V. Then V again, then you start V again, V, on reaching again you add another V. Then V, you finish. So you have used the bottom part to create this track, which is the best way to do it. Then you continue. That one is correct. You go on. That one is correct. You go on. Do first the connections that are easy to do. So I can put it over here somewhere there, and then go. So I kind of need a view somewhere there. Yeah. Yeah. Control save. Click on this one. Like that. Control save. Click on this one. Like that. Control save. Click on this one. Control save. So we change the track by the IC. We need a smaller tracks so that we can pick these things easily. So let's finish up on these bigger trucks. That one is complete. Then we connect to there like that. So we work on it. Another one is this one. Okay. Save. What else do we need from these bigger parts? Which part is not connected? So check. So we have an IC remaining and wired. We can try to make 0.2. We can try to make very thin. We see whether we are capable of doing the wiring here. Correct. So we first pick this, we connect here, pick this one, we connect here, and pick this one. We just refuse to from this side. So we can try to put a wire there. No, you don't need a wire. So we can pick this one, we can pass through here. And we can go to this point. Control save. Pick this one, connect this. Pick this So we have our system routed. We can try to view it and see the radio viewer. Yes, you can see the system is routed. So we can add some text on the system. ESP32. ESP32 automation projects. And then after doing that, you can take the width to so I design it 0.8 here again 0.8 thickness 0.2. So you can view, you can try to view the radio view. Yes. Now we do the final part of this project, which is now copper poles, adding of copper poles for this project. We'll start with the green one, and it's on the ground. Then we do this. We go there. We go here. We go. Control save. Then we go to the final bit. This one. No. This one. Already have done. Then we go to this one. copper again. We do it. You want to use this one? Okay, let's see what will happen. Okay. So I forgot to select this one there. Okay, we go like that. Come here. There. Correct. Control save. Then you can view. And this is our design work. This is our final design. So this is how you do an ESP32 home automation power system. It's done this way, and I think it is one of the simplest projects we have done so far. But it's very interesting, although it's taking a lot of time. But it's good for you to learn it. So the rest is generation of the necessary manufacturing documents, of which I've been showing you in the previous projects. Therefore today we will not go through that. That's how you do it. We have finished our project of an ESP32. Thank you.